Welcome to Mimi's Math Channel. Today I'm going to discuss how to go from general to standard form of a circle. So below in blue, you see each form. So general form is x squared plus y squared plus ax plus by plus c equals 0. Whereas standard form is derived from the distance formula, and it is going to be the quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared. So in my first example, I am going to convert from general form to standard form of a circle for part A, and then I'm going to take that answer and I'm going to take it from standard form and go back to general form of the circle. So in order to do that, you're going to need to know how to complete the square. And the first step is going to be to get all of our x's together. We're going to complete the square twice. X squared plus 4x. And then I'm going to leave a blank because I'm trying to complete the square. So plus blank. And now I want to do the same thing for my y variable. So plus y squared minus 6y plus blank. And for the constant, I want to move that to the other side. So instead of negative 68, I'm going to take the inverse, which is positive 68. And like I said, I'm going to move it to the other side. So this is going to be set equal to 68. Now you'll notice I have two blanks on the left-hand side of the equal sign. So what I do to one side, I have to do to the other. So I'm going to have plus blank 2 times. I have to balance my equation. So the completing the square formula is b divided by 2, and take that answer and then square it. Go ahead and put your parentheses in the square for my x values and then plus, and you're going to do the exact same thing for your y values, and you're going to set it equal to something. So we just have to fill in the blank so we'll know what to put in there. Now you can see that it's starting to look like above the standard form. So what I want to do is recognize that the standard form of a quadratic is ax squared plus bx plus c. Well, we're looking for b. B is the portion that's in front of your x value. And we're going to do that twice to complete the square. And that's what's going in that formula over to the left-hand side. So for the first one, we have b is 4. 4 divided by 2 is 2. And then we're going to square that. So what I want you to do is take your x and put that in the parentheses. Take whatever this sign is, put that in the parentheses, and now just follow your formula. What's 4 divided by 2? It's 2. And then what's 2 squared? It's 4. So that is what goes inside of your blank. What I do to one side, I do to the other. Now I'm going to do the same thing for y. I have to locate my b value, which is going to be negative 6. Include your sign. So I'm going to take y, take this sign, minus, and this time I have negative 6 divided by 2, which is negative 3. And then we're going to square that. So once I square, anytime I square a negative number, it's going to always be positive. So negative 3 squared is 9. What I do to one side, I do to the other. And now on the right-hand side, I simply simplify that. So 68 plus 4 plus 9 is 81. So now if I look at this, I see that this is actually in standard form. Now I'm going to take that same answer that we just got from part A, and I'm going to write it in general form. So now I have to expand my binomials. So I have x plus 2, or the quantity of, times the quantity of x plus 2. That's what it means when you're squaring an expression. And then I'm going to do that again for my y. The quantity of y minus 3 times itself. And all of this is set equal to 81. So now I want to distribute. And when I distribute, I see that I have 4 terms, but the middle terms I can go ahead and combine. So I have x squared plus 2x plus another 2x, which is plus 4x. And then I have 2 times 2, which is 4. Over here, I'm going to do the same thing. Y times y is y squared. Y times negative 3 times y times another negative 3 is going to, if I add those, that's going to give me negative 6y. And then negative 3 times negative 3 is positive 9. Again, all of that is set equal to 81. I'm trying to get it in the general form. So what I want to do is get my x squared first, and then my y squared. And now I want to find my x, which is plus 4x, and then my y, minus 6y. And I want to set all this equal to 0. So I'm going to combine the terms that are on the left first. So that gives me a positive 13, and then I'm going to subtract this number over to the right-hand side of the equal sign. What I do to one side, I do to the other. So 13 minus 81 is going to be negative 68, which is what I started with, and then this is set equal to 0. So this is my answer in general form. See, that's what I started with here. It's the same answer. I just went in reverse. Okay, so for example 2, we are given that the center is negative 1, 0, and that the radius is square root of 7. We're asked to write it in both standard form form as well as general form. So I went ahead and, as a reminder, put what each form looks like. First thing I want to do is label my center, which I know the X portion is going to be H, and then the Y portion is K, so HK. And then my radius is simply my radius, but I need to make sure when I put it in my formula to go ahead and square that. So this is what it would look like. I'm going to take X, replace the H with minus. Minus is part of my formula, but then I have a -1. So that's going to change this to a +1. Okay, because it's Y minus 0, I don't have to put it in parentheses. I'm simply just going to say Y squared because it's understood that there's not a K. So it just goes away. My radius squared. So I'm going to have to take the radius that's given, which is square root of 7. And in order to get the squared, I'm going to have to take the square of both sides. And once I do that, that's the inverse. So it's going to get rid of that square root. My R squared is actually simply 7. Or I could have just said square root of 7 times square root of 7 is square root of 49, and square root of 49 is 7. You still get the same answer. So this is standard form. Now I want to take that information and put it in general form. So I have to expand my binomial. So this is going to be x plus 1 times the quantity of x plus 1 plus y squared, and all of that is set equal to 7. And I have to distribute x times x is x squared. And in the middle, I know I'm going to have 1x plus another 1x. So that's going to be 2x. And then 1 times 1 is going to be +1. And that's going to be plus y squared. Now I'm setting that equal to 7. However, for my general form, I want it to end up equal to 0. So once I put my x squared and my y squared together, the only thing that I'm left with is trying to find my x and my y, but I don't have a y. So I simply have plus 2x, and I have to bring that 7 over. So I'm going to subtract 7 on both sides to get the 0. And now I have -6 is equal to 0. So that's the general form. And the initial one was my standard form. For example 3, what I want to do is write an equation of a circle when the center is 2, -3, and it passes through a point, -1, -3. So here I can go ahead and partially start setting it up because I'm given my center, which is HK. So I can go ahead and just, for my H, I know it's going to be replaced with 2. And for my Y, it's negative in the formula. However, it's -3. So -3 times that negative is going to change that to a +3. R squared, I have to find by using my points. So I'm given an X and I'm given a Y. And I'm going to use my distance formula. However, instead of using D, I'm going to use R because this is going to give me my radius. And then I will simply take my -1, which is my X. I'm getting that from the point that was given. And then I'm going to subtract it from my center, which is given up here. And then I'm going to square that. Now I'm going to add it. And like I said, that looks like my equation of a circle. That's where I'm getting it from, like this distance formula. And now I'm going to go back and I'm going to take my Y, which is -3. I'm going to subtract it from my K. It's negative. It's going to turn into a +3. And I'm going to square that. Once I simplify this, R becomes the square root of, well, -1 plus -2 is -3. So this is going to be -3 squared. And then -3 plus 3 simply goes away. So that's just 0. And if I continue to simplify, I have the square root of 9. However, that's my radius. I want the radius squared. So I'm going to square both sides, and that will get rid of that radical. My R squared is going to be 9. And that is what I'm putting in my equation of a circle. And when I'm writing my equation of a circle, it's automatically going to be in standard form. And then the last example, I'm asked to determine whether the given points lie on, inside, or outside of a circle with the equation of the quantity of x minus 4 squared plus the quantity of y plus 3 squared equals to 5. So what I want to do is just substitute in my values x and y and see whether or not they're equal to the radius, less than, or greater than, and that will determine where it lies on the circle, or inside or outside the circle. So here I have 3, which is the x that's given here, minus 4 squared plus the y that's given is -1 plus 3 squared set equal to 5. Once I simplify this, -1 squared is 1. -1 plus 3 is 2. 2 squared is 4. And yes, I see that 5 does in fact equal 5. So if it is true, that means that it's on the circle. And then for the next point, I have 2 minus 4 squared. I'm just replacing the x's and the y's, and I'm already given the h and the k. So then I have -3 plus 3 squared squared. Simplified negative 2 squared is 4. This is 0. So now I see that 4 is actually less than 5. And if it's less than, that means that it's still inside of the circle. And then the last one, I'm going to substitute in the values for x. So x minus the h that's given plus y minus the k that's given. And that squared equals to 5. And now once I simplify this, I see negative 4 squared is really 16. Negative 1 plus negative 1 squared is positive 1. And I can clearly see that 17 is greater than 5. On that one, since 17 is greater than 5, I know that that answer is going to be outside of my circle. So now I'm going to use Desmos to verify this. I see that 3 and negative 1 is on the circle, 2, negative 3 is inside the circle, and 0, negative 4 is outside of the circle. Thumbs up, subscribe, have an awesome day.